Hi everyone, how are you all? Myself Nagappa, you are watching Appa Chemistry classes. Now our today's topic is alkyl and aryl halides. Before this, first year all chapter wise numerical questions which I had explained. You can see all those numerical questions links in the description box. For more videos you can subscribe to my channel also. Now we will see the numerical questions based on the alkyl and aryl halides we will see. In that first question you see the number of chlorine atoms present in DDT. What is DDT? It is an insecticide. It is an insecticide which kills the insects, but it is a non-biodegradable compound. Non-biodegradable. Now what they are saying? Non-biodegradable. So it contains how many number of chlorine atoms they are asking. Now DDC structure is here. It has the water two dichloro, diphenyl. These two are the dichloro, diphenyl, trichloroethane. It will be trichloroethane. So what is DDT here? DDT is defined as dichloro, diphenyl, trichloroethane. It will be okay now. So this is 1, this is 2. Okay, you can take like that, or else sorry, you can take 2 here 1, because 1 comma 1 comma 1 trichloro it will be 2 comma 2 diphenyl para dichloro. Okay, that is what we are calling DDT. How many chlorines are there? 3, 4, 5. So total number of chlorine atoms in DDT will be 5 it is. Okay now, next one. You see, this is a reaction, sequence reaction. This type of sequence reactions are very important. You try to concentrate on this sequence reaction. Whenever this compound is react with bromine in presence of sunlight, so it participate in what? Photochemical substitution reaction. By that photochemical substitution reaction, you are going to get the what? One of the hydrogen is substituted by the bromine, because it is a saturated one. Saturated one participate in photochemical substitution. Whenever it react with magnesium metal in presence of dry ether, E2O is nothing but what? Dry ether. Okay na? So that is E2O, that is dry ether. We will get the Grignard reagent, MgBr. We are going to get the MgBr is the B product, which is on reaction with what here? CH3CHO it will be, that is acetaldehyde. C double bond OH it is this compound, and further followed by hydrolysis. Now in Grignard reagent is a neutral nucleophile. This carbon gets the negative charge, this magnesium has the positive charge. The negatively charged nucleophile will attack on this carbonyl carbon because it has the partial positive charge. This pi bond will be shifted here. Then what happens? We are going to get the here the cyclohexane will be bonded to this acetaldehyde carbonyl carbon. Then it becomes O minus Mg plus Br. Okay na? So it has the one hydrogen as well as it has one CH3 group. Now which is on further hydrolysis, which is followed by hydrolysis. Here I will write H3O plus. Then I am going to get the here, sorry. So in this case CHOH it becomes, it is CH3. Now whenever it is react with, this is what we are calling, it is a C compound. This is on reaction with concentrated sulfuric acid. Dehydration takes place. By the dehydration, which product you are going to get? The double bond may be possibility of getting in between these two carbon atom. And we have the what? One more possibility is there. Double bond may be possible between these two carbon atom. Okay na? So it will be CH3. So which type of double bonds are more stable? More substituted double bonds are more stable. What they are asking here? The number of pi bonds present in D is, how many pi bonds are there? Only one pi bond is there here. Only one pi bond which is present in this compound. Is that clear? Now next question next one. Third question. How many primary halides excluding stereoisomers are possible for the molecular formula C5H11Br? Now C5H11Br, this is pentyl bromide. 1, 2, 3, 4, 5. 5 carbons with bromine. So it is 1, 2, sorry, it is 1, 2, 3, 4, 5. So 5 carbons and 11 hydrogens, 1 bromine. Now what they are asking, they are saying that primary halides it will be. So this is primary halide. One more is possibility is what it is? Isobromide. It is another possibility. 1, 2, and next one more possibility is what here? It may be here. So this is a third possibility. One more is what? Neopentyl it will be. They are asking only primary halides, they are asking, excluding stereoisomers it will be. So this is a fourth one. Okay now. So that is C5H11Br will have the how many isomers here? Total of 4 isomers are possible. Okay now, 4 isomers are possible with the C5H11Br. Is that clear? Okay now, so this 4 should be different one. Next one, how many of the following do not give iodoform on reaction with iodine and NaOH? If they want to give the iodoform reaction means on the carbonyl carbon, adjacent carbon should be methyl group, or else if we are taking the alcoholic carbon, the alcoholic carbon adjacent carbon should be what? CH3. Then only they show the what? Iodoform reaction. That is, both react with they react with iodine. These react with iodine and in presence of NaOH, and they produce the iodoform CHI3, which is having the yellow coloration and hospital-like smell. Okay, now it has the hospital-like smell. It has the antiseptic nature. That antiseptic nature is due to presence of free iodine. Now you see here, this is a carbonyl carbon. Adjacent methyl group is there. Yes, it will show the iodoform reaction. It is ketone, carbonyl carbon. We have methyl group is there. Yes, it will also show. Now it is a secondary alcohol. Now I will write the same structure here. CHOH, CH3 it is. This is a alcoholic carbon. Adjacent carbon is methyl is there. So it will, alcoholic carbon, adjacent carbon is methyl. So it will show the iodoform. Now this is carbonyl carbon. Adjacent carbon we have methyl. So all will show the what? Iodoform reaction. So here the given compound, all will participate in iodoform, which is not giving means 0 number will give the what? Iodoform reaction here. All will give the iodoform. You can take simple example here. You can take in case of here this alcohol, secondary alcohol, CHOH, whenever it react with iodine. Just for example, what happens, you see here, this iodine is an oxidizing agent which oxidizes the alcohol into first iodoform will get CHI3. This compound will be oxidized to CHI3, and remaining this methyl will be as it is. And this CH is there, no, this alcoholic carbon that is oxidized to COONA, sodium salt of carboxylic acid, plus sodium iodide plus water, we are going to get H2O. So this sodium iodide will be 5 moles. So here, and 3 moles of water it will be. Then 4 moles of I2, 6 moles of NaOH. This is the actual reaction of iodoform. Is that clear? Now next one, number of isomers for the compound with molecular formula C2BrFCl is. Now it is what 2 carbons are there here. 2 carbons with 4 halogens are there. Bromine, chlorine, fluorine, iodine it is. Now this carbon tetravalency is not satisfied, so it is an alkene. So alkene generally participate in geometrical isomers. They participate in geometrical isomers. Now all are different in position. So then what happen? Number of isomers possible for this geometrical isomer will be how many? 6 isomers are possible. How you know? By changing this interchanging of these halogens. Fluorine, chlorine, bromine, iodine. This fluorine can replace the one chlorine is replaced by fluorine. One isomer will get. This fluorine on replacement of this bromine by the second isomer will get. This fluorine can replace the water iodine by third isomer will get. So 3 isomers we got. Now after that the chlorine can replace the water bromine, one isomer. The chlorine can replace the another iodine, that is 2 isomer. That is 3, it is 4, it is 5 it will be. Now next is what? This bromine can replace the iodine. That is 6 isomer. Total of how many isomers are possible? 6. We can write it as 4C2 also. 4C2 is nothing but what? 4 into 3 by 2 into 1. That is 2 2s are 4. That is 2 3s are 6 it will be. Here 4 are the different one and 2 carbons are there. 4C2 you can do in this manner or in this manner. So total number of isomers are how many? 6 isomers are possible. Next one, next compound. How many substrate will show the rearrangement during the SN1 reaction? Actually, SN1 reaction takes place by 2 steps. In step 1, what happens, Amma? In step 1, we'll get the formation of carbocation. It will be formation of carbocation. So in step 2, what happens? Attacking of nucleophile. Attacking of nucleophile takes place. That is substitution of nucleophile on that carbocation takes place. First, formation of carbocation. This is the intermediate it will be. It is the formation of intermediate is the slowest step of the reaction in SN1. It depends on the stability of carbocation. Now you see here, whenever this halogen is lost, we will get the carbocation here. So then what happens? It is secondary. There is a possibility of getting tertiary carbocation. Then hydride ion shift takes place. So there is a rearrangement is there. So then this compound will undergo in SN1 and it is undergoing by rearrangement reaction. But whereas this chlorine, whenever it is break, we will get the secondary carbocation. This carbon is also secondary carbocation. So no rearrangement in this case. It participates in SN1 reaction as well as SN2, but there is no rearrangement at all. Now in this case, iodine is there. Here what happens? Whenever it is lost, we will get the positive charge. This methyl group shift takes place. Methyl group is shifting, then we will get the tertiary alkyl halide. Tertiary alkyl halide. Its rearrangement takes place. Now in this case, what happens? Here it is a tertiary one. So and here secondary is there. Will it form the tertiary to secondary? No, it will be tertiary means it is the more stable one, no rearrangement, direct substitution it will be. But whereas here if you will get the what this bromine is break, we will get the secondary carbocation it is. So this alkyl group is shifted onto this carbon. Then what happens? We are going to get the tertiary carbocation. Here rearrangement is there. In this case rearrangement is there. Now in this case all will be secondary carbocation, no rearrangement. But whereas in this case we will get the what positive charge here. It is secondary carbocation. So now in this case we have the hydrogen atom is there. This hydrogen will shift to here. Then what happens? We are going to get the tertiary carbocation. The tertiary carbocation is more stable. So rearrangement takes place in this case. Now in this case what happens? In this case here we will get the positive charge here. But the tertiary carbocation is more stable, and also here the hydride ion shift takes place readily because it gets the what allylic position carbocation. It is double bond, adjacent carbon is positive. That is, we'll get the what allylic carbocation. That is more stable when compared to the secondary carbocation, as well as it becomes a tertiary. So rearrangement is possible. Now in this case what happened? No rearrangement at all. Only this compound will get the positive charge, no rearrangement, remaining will be same. But whereas here if it is lost here, we will get the positive charge. Now here what happens? The hydrogen which is present here, this can be, now here what happens? Positive charge we got, no? Now this bond will be, here the bond breakage takes place and ring expansion takes place here. What happens? Ring expansion takes place. Now what happens here? It is 1, it is 2, it is 3, 4, 5. Okay now. So 4-membered ring becomes a 5-membered ring it becomes. It is rearrangement reaction. So now here first carbon has the what? One alkyl group. So fifth carbon is bonding here. This is a first carbon to second, third, fourth, fifth. So first carbon has the one methyl group as well as fifth carbon is also having the one methyl group. So here in fifth carbon we are getting positive charge. Here the nucleophile attacking takes place. That is, it is participating by rearrangement reaction. How many? 1, 2 and 3 here, 4, 5, 6. Total rearrangement reaction takes place. How many here? 6 particles will undergo in rearrangement reaction. Is that clear? Now next one, question number 7 you see once. In this case it is an from ether reaction it is. Now here whenever hydrogen iodide is reacting, this bond will be breaked here. It is a strong reducing agent. It is a strong reducing agent which reduces the ether into alcohol and alkyl iodide it will be. Now you see in this case these bonds cannot be broken because these bonds are these oxygen containing lone pairs are involved in the resonance. So this oxygen to benzene bond getting the partial double bond character. So for that reason these bonds cannot be broken here. Only these bonds can be broken, and also this bond not broken here. These bonds will be broken. We'll get the what? If it want to react to this 1 mole, if it want to react by this 1 mole of compound, so it require the what? 2 ethers are there, so 2 moles are needed. Here OH, whenever it react with hydrogen iodide, we are going to get OH plus ethyl alcohol, 2 moles of ethyl iodide we are going to get. So to this we are getting the what? 2 moles of hydrogen iodide is needed. But how many x moles of hydro consumed for 6 moles of the reactant? If you are taking for 1 mole of this reactant is combining with 2 moles of hydrogen iodide. If you take 6 moles, it requires the how many moles? That is 12 moles is needed. 12 moles of hydrogen iodide is needed. Is that clear? Now next question, which is on reaction with NBS in presence of carbon tetrachloride. The total number of isomers including stereoisomers obtained in the above reaction is they are asking. Now here NBS is used in case of what? Allylic position, the bromine will be substituted. NBS is what? N-bromo succinic amide it will be. This is N-bromo succinic amide. N-bromo succinic amide, which is preferably suitable reagent. It is a selective reagent which is used for the allylic position substituent. Now whenever it is on reaction with NBS, so NBS, so we are going to get the what? Allylic position compound will be substituted. Now here allylic position, this is allyl bromide. Now another one will be what happens? So this is another compound possibility. Now these two are different or not? This is 1, 2, 3, 4, 5, 6 it will be. Now here it is 1, 2, 3, 4, 5, 6 it will be. Sorry, it will be here numbering should be from the bottom carbon. 1, 2, 3, 4, 5, 6 it will be. Okay, now these two are the what? Different compounds here. Okay, now. So now in this case, what happens here? Now here the two D and L isomers are possible. D and L. Here also D and L isomers are possible. 2 isomers. And one more is possibility is there here. So it is also carbon. This carbon is also called allyl carbon, which gives the what? One more bromine here, CH2Br. This is having only one isomer. It is not the stereogenic center. These are the stereogenic center. Here 2, 2. Here 1. Okay, na? So 4 plus 1, 5. And one more is possible here. So you can write the same isomer can be written as like this. So double bond CH2 with the same molecular formula. You can substitute the bromine here. This bromine is what? Chiral carbon. Here also we will get the what? D and L isomer. And one more possibility is what? Here you can take, this is allylic position. Here the methyl group. Here if the bromine is substituted, this is also what? Chiral carbon. So here also we are going to get the what? D and L isomer. Here 2 isomer, 2 isomer, 2 isomer, 2 isomer. So 4, 2 is 8, 8 plus 1. So total how many isomers are there including stereoisomer they are saying. So total of 9 isomers are possible for this. Next one, how many stereo centers would be created when following compound is treated with osmium tetroxide in presence of hydrogen peroxide. The osmium tetroxide is used as hydroxylating agent. It is a cis hydroxylating agent. Okay, now here all the alkenes will be changes to alkenes are converted to dihydroxy compound. Alkenes are converted to dihydroxy compounds it will be. Now you see here it is a double bond is there. Now this double bonded compound will changes to OH. So now in this case here the carbonyl carbon is not disturbed, oxygen, double bond O. So here double bond is there. So Now here double bond is there. This double bond is reduced to oxidized to 2OH dihydroxy compound. Methyl will be as it is. Here also double bond is there. Here OH. Here also OH will get. Now here also double bond OH, OH. Wherever you have the double bond, in all those cases OH will be substituted here. Now you see in this case how many chiral centers are produced. Stereogenic centers, which is nothing but chiral carbon. This carbon is chiral carbon. No, it is not the chiral carbon, because all the two methyl groups are same. This is chiral carbon. Now this is chiral carbon. This is also chiral carbon. Now you can take this one is also chiral carbon, but not this one. How many? 1, 2, 3, 4, 5, 6 it will be. How many stereogenic centers are produced here? How many stereogenic centers? It will be total of 6. 1, 2, 3, 4, 5, 6 it will be. Total 6 it will be produced. Is that clear? Now find the number of chlorine atoms which is present in major product of the following. Here alcohols will be converted to acid, alkyl halides, whenever it react with PCl5. Whenever the carbonyl carbon, if it is carbonyl carbon is there, whenever it react with PCl5, then it forms the what? Dialkyl, dichloro substituent will get. Okay na? So now you see in this case we have this cyclohexane. Here epoxide is there. Epoxide is not disturbed here. As it is, it will be. This is carbonyl carbon. The carbonyl carbon will bonded with the 2 chlorines. So here O. This ester is not reduced here. This alcohol is there. This alcohol will change as to chlorine. The carbonyl carbon is oxidized to 2 chlorine atoms are substituted here. Total number of chlorine atom which is present in the major product of the following reaction they are saying. So here 2 chlorines, 3 chlorine, 4, 5. So total number of chlorine atoms which are present in this compound will be 5. Next, number of stereoisomers for 2-chloro-3-pentene is, what they are saying, 2-chloro-3-pentene. Pent they are saying means 5 carbons we should write. 5 carbons. So 1, 2, 3, 4, 5. So at third carbon they are saying that pentene. At second position chlorine is there. This is the chlorine. Now satisfy the tetravalency here. CH, here CH, here CH, here CH3. Now you see this is double bonded carbon. There is a possibility of getting of geometrical isomer. Is it or not? Geometrical isomers are possible here. Geometrical isomers are how many? One will be cis and trans. Cis and trans. 2 isomers, 2 geometrical isomers are possible here. Now this is what? Chiral carbon. This carbon is bonded with 4 different atoms. Chiral carbon will form the D isomer and L isomer. It also forms the 2 isomer. So these D and L are what? Optical isomers. These D and L are optical isomers. Now what they are saying? They are asking you to calculate stereoisomer. So stereoisomers comes under what? Geometrical and optical. Sum of the geometrical and optical will gives you what? Stereoisomers. So here geometrical 2 and optical will be 2. So total will be how many stereoisomers? It will be 4 stereoisomers are possible. I think so you got some information about what are the possible ways of asking numerical questions from this alkyl and aryl halide. So I hope so it is cleared all the questions. So thank you. If you have any doubts you can comment in the comment section. Thank you. Have a nice day. Keep watching Upper Chemistry classes.